Okay. The third unit, third module is decimals. Rounding, adding, subtracting, multiplying, dividing. All right, and they have placeholders. Just like ones, tens, hundreds, thousands. Decimals have placeholders as well. So that 9 would be to the 10th. Okay, the 3 would be the 100th decimal place. Thousandth. You're putting the at the end of everything. $10,000th, and so on. The last one will be the 100,000th. Did I mix one? 10,000, 100,000, and then 1, 2, 3. If you want to say the millionth, I doubt you'll run into that. Okay, but that's the way it goes. 10th is 1 decimal place. 100th is 2 decimal places. 1,000th is 3, and so on. If you ever need me to scroll back up, just let me know. Round 12.2469 to the nearest tenth. Okay, the same rules apply. So if I am looking at the 10th decimal place, I have to look at the next number, which in this case would be the 4. So I look here. Higher or lower. So it's low, which means you leave the 2 alone. All right, so the 10th is going to be 12.2. Everything else after it is zeros, all right, but we don't need to write those zeros. We can just write it as 12.2. All right, that's the 10th decimal place. Question?
Why wouldn't the 2 after to the right of the decimal? Oh. No, why would the 2 to the left of the decimal be the tens?
Well, if you remember, this is just the ones digit, right? Ones, and this is tens. That's back from chapter 1.
Oh, okay.
All right, so the question is about the placeholders. But you have the same thing going the other way. But it just starts at like the 10th and the 100th, okay? All right, let's do 100th. What is the 100th decimal? Yeah. So look at the next number after that. Go higher. All right, so let's make that 12.25. Okay, so that's our 100th. And then, how about thousandth?
6.
Is the 6. All right, the number after it is higher than 5, so let's make it 12.247. That's our rounding. Very similar to the first chapter. I go crazy in the yogurt section. I see yogurt on sale. I'm one who buys like 30 of them. And then so they're like, buy 10 and get an extra 30 cents off each one. I'm there. And then I'm at the register. I'm like, I self-check. And then I feel bad because somebody's behind me and I got 30 yogurts and I'm going through the check. And, yeah. But anyway. Yeah. Ringing up all the yogurts. That's me. Yogurt is on sale. Buy 3 for $1.50. Okay, estimate the cost to the nearest cent. Now, I'm going to do this by hand, but remember that you have these things right here to help you. So hopefully it's not too bad. Buy 3 for $1.50. All right, so if I buy all 3 for $1.50, the total's $1.50. To multiply by 3 or divide by 3? If the total of the 3 yogurts is $1.50, and I want to know what each of them is, so it's like per unit. Whenever you see per unit, you would think divide. Okay? So let's do 150 divided by 3. All right? 1.5 divided by 3. Remember that the denominator is always what the divisor is. So how many times would 3 go into 15? Yeah, I think you said it. So it's just 0.5, right? Okay, let's say it in cents, though. It would be 50 cents. So I add that 0 on. Okay, so we didn't necessarily need to estimate there. But let me change the problem around. Let's say it said 3 for... How about $1.29? 3 for $1.29, okay? Same process. So let's go through the division. How many times would 3 go into 12? You can pass if you want. 3 into 12. 4 times, right? I'm going to keep that decimal in the same spot too. I'm going to carry that up. All right, so minus 12. I picked an even number that went into it, didn't I? 3 goes into 9 3 times, so 43 cents. So again, it came out even. I would write 43 cents. Let me pick 3 for $2. Okay, so one more. Three goes into 20 6 times. And I multiply and subtract. Now I bring down that 0. And notice it's the same number. So it looks like it's going to repeat forever. Multiply 3 times 6, subtract, you get 2 left over again. So you can add a 0 here. And I can keep adding zeros on forever. But notice the pattern. It's just going to be 0.6 repeating, and it's going to go on forever. So what do they mean by round it to the nearest cent? Well, you have 0.666666. 67 cents is what it would be. Okay? Try to get you some extra examples in there. So that's to the nearest cent. That was pretty key for me to write where the decimal point was. All right, always keep that in mind. For example, look, it says subtract. But if I were to do 8 minus 9 and kind of borrow from that, I would be wrong in doing that because the decimal point needs to match up. It's almost like I want to rewrite this. 3.2198 minus, now I'm going to put it here, 0.399. What will I write? What do you think I should write here? Sure, add a 0. You can add a 0, as many zeros as you want.
If the decimals don't line up, will we get like the wrong answer?
You would, yeah. Okay, so now 8 minus 0 is 8. 9 minus 9 is 0. All right, 1 minus 9, well, that doesn't work, so let me borrow from the 2 and make that 11. So 11 minus 9 is now 2. 1 minus 3 doesn't work. I have to borrow again. And now that turns into 11. So 11 minus 3. Keep that decimal point lined up. I think I should get 2.8208. This gentleman right here was doing a good job. Did you check me on it maybe? Did I do it right? Whew. All right, so you have this. Check it.
So you can just, after you line the decimal up with each other, you can just subtract like you normally would.
Absolutely, just normal. Yeah. If I had 2.48 minus, how about 0.1046? All right, let's throw another example in here. Now the other decimal has more places. So what would you do?
Put zero, line it up first, put then the zeros on top and on the bottom of the 2 there.
Yeah, and put a 0 next to the 8.
Yeah.
2 zeros actually. So now you'd have it like that. Okay, and if you were to do this by hand, you would borrow and so on. You got to borrow from the 8 and make this a 10. So you actually have to borrow twice, make that a 9, and now this is 10. 10 minus 6 is 4. 9 minus 4 is 5. 7 minus 0 is 7. 4 minus 1 is 3. Keep that decimal point lined up. All right. Please check me again. Check your own work if you have a calculator. That's what it's there for. And adding is the same thing. Okay? Adding and subtracting. They will give you some word problems in the homework. According to visual economics, the average American consumes 2.736 pounds of sodium and 273.2 pounds of fruit. I think that's a pretty good stat. People are eating less salt. Okay. How many more pounds of fruit than sodium do Americans consume in a year? So get ready. The question says, this is for you. How many more pounds of fruit than sodium do Americans consume in a year? What am I going to do? Add, subtract, multiply, divide, square? His question. Yeah, right. So let's subtract. Can you set it up for me?
273.20
Awesome. Good job. So that's how we set it up. All right. I'm just going to go through it quick because I think the calculators can do that, right? I mean, you can put in decimals and stuff. Pounds. We didn't have to make any conversions, right? They were both in pounds? Pounds and pounds. All right, so we're okay. All right, now multiplying. And just like you mentioned before, it's going to be exactly like with whole numbers. We're going to multiply in the same way. 1.245 times 19. I guess if you're going to do it by hand, you know, when you multiply, you actually don't have to line it up because I'm going to account for it later. So let me do this. 5 times 9 is 45, so carry the 4. 4 times 9, 36, 37, 38, 39, 40, carry that. 2 times 9 is 18. 19, 20, 21, 22. 1 times 9 is 9, and then add that 2, so that's 11. Now move to the 1. So I put a 0 for the placeholder, and now 1 times 5, 1 times 4, that's pretty simple because it'll just be the same number. And then I have to add that. 5, 5, 6, 3, 2. I guess this is just the way I think about it. I didn't do anything with the decimal point yet. So now at the end, I say, okay, how many decimal points are there? There are 1, 2, 3 decimal places. And I go back down to my answer. and I'll go 1, 2, 3. So hopefully, if I did it right, 23.655. Once again, check it in your calculator. And that's how you know you're doing it the right way. Okay? Pick a decimal point. Pick a number with a decimal in it.
Any, give you a number.
Whatever you want.
5.6.
5.6. Okay. Pick another decimal. Go ahead. Pick a 42.6. Okay. I could multiply it like that, but it's probably better if I put it up the other way. So I'll do it 42.6, 5.6. Now they both have decimal points, okay? But same process. 6 times 6. And then 2 times 6 is 12. Oh, yeah, and then add the 3 is 15. Okay, 6 times 4, 24, plus 1, 25. Placeholder. 5 times 6 is 30. There's still a 3 there. 10, 11, 12, 13. 20, so 21. Add them. 6, 5, 8, 3, 2. All right, but now just do it from both numbers, right? So we've got one decimal place there and one decimal place there. What's the answer? Exactly right, 238.56. Question?
Yeah. What happens if there's like 2 decimal spots on like the top and like on like 3 or at the bottom?
Okay, so the question was, what if there was 2 decimal points and 3 decimal points? That's what I wanted you guys to pick. I wanted you to give me some crazy numbers. I forgive you. You would just count that many times. So now there would be, if there was 2 decimals in the first number and 3 in the second number, then you would move it over 5 times. Yeah.
You would always add like these.
Right. Why did I throw this one in here? Well, I don't want to do that by hand, people. Nah. But as many zeros as there are when it's like times 10 or times 100 or times 1,000, that's how many places you move the decimal. So I think that if I just do 1, 2, 3 because it's 1,000, that's my answer. So when you multiply by 10 or by 100 or by 1,000 or by 10,000, just move the decimal place over by the number of zeros there are. Remember, multiplying by 10, 100, 1,000, etc. is easy. Just move the decimal point. Let's see, do we have to do a division, I think? Maybe. Okay, the word problem. Julie is a real estate broker who charges a fee of 0.07 times the price of the home. So she works off commission. Oh, I have a cousin named Julie, and I must have been doing it subconsciously. My cousin Julie's in real estate. 0.07 times the price of the home. If she sells a home for $354,000, how much is her fee? All right, so the important information would be right there. So, your question, when you see 0.07 times the price of the home, she sells a home for $354,000. Can you set it up for us? What would we do? Add, subtract, multiply, divide. What do you think? Multiply, exactly. Times. Like 0.07 times 354,000. You're exactly right. You can go for the calculator, I suppose, but I'll give it a shot. If you just bear with me. Zero, 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 28. 7 times 5 is 35, 36, 37. 3 times 7 is 21, 22, 23, 24. And the second number is all zeros. So I have my placeholder, and then it's just zeros all the way. I hope I did it right. Just keep track of your decimals. How many decimal places should I move? How many decimal places are there? So 2 places. So let's go from here and go 1, 2. So if she sells a house for like $354,000, she'll make commission of $24,780. Pretty good. My guess is in the job it's probably more like 2 or 3%. But I don't know. Yeah, real estate can be a lot of money. I don't know if anybody has experience with that or not, but. I don't want to really confuse you guys or go too far, but 0.07 is the same as 7%. If you kind of think about it like that. She makes a 7% commission. Multiplied by 0.07. Percents come later. All right. Michael bought 824 bricks to build a barbecue pit. He paid a total of $269.78. Set up the problem. If you can, you could also pass. Is it going to be multiply, add, subtract, divide, square root? What is it going to be? Any ideas?
Divide.
Yes. And what tells me that is to divide is the per brick part. So per is like a fraction kind of. Bonus question, what are you dividing?
269.78 divided by 824.
Awesome job. And the reason why I wrote those words out is I look at the dimensions of it. If I do dollars divided by bricks, well, this is going to be dollars per brick. And I know I'm doing it the right way. Remember that the denominator is the divisor. Oh, I got myself in a real pickle here. 824 does not go into 269, so I think it'll go into 2,697 maybe 3 times. Three times 4 is 12. 3 times 2 is 6 is 7. 8 times 3 is 24. I know 8 times 3 is about 24. That's why I kind of rounded it, I guess, 3. Subtract. 7 minus 2 is 5. 9 minus 7 is 2. 6 minus 4 is 2. 2 minus 2 is 0. Okay. Bring down that 0. Or I'm sorry, the 8. 824 goes into 2200 twice. So now 2 times 4 is 8. 2 times 2 is 4. 2 times 8 is 16. 0, 1, 4, 1, 610. You can add as many zeros as you like to get the accuracy of it. So let me do one more here. How many times is 824 going to 6100? Well, 8 times 8 is 64. So I think maybe one less, and I'll pick 7. So now 7 times 4 is 8. And 2. 7 times 14, 15, 16, 56, 57, and so on. Why did I do it all out by hand? Because now with the decimal point in division, it just lines up and just put it in the same spot. Okay, so dollars per brick. I'm going to say about 33 cents per brick if I round it to the nearest cent. How'd I do?
So if we're talking money, you always just round it off to cents that make sense?
Yes, that's right. I'm pretty certain they'll be specific about it in the questions too. Round it to the nearest cent or to the nearest dollar, or maybe they don't want a decimal place at all, you know. But yeah. Oh. What was I going to do? Divide it. 824. Yeah. Check in the calculator. Other questions? 2 or 3 more slides, and that's the whole chapter of slides that I wanted to go through. So, questions or comments?
So with the decimal, you just bring it up?
Keep
Or
it.
you have to round it?
Keep that decimal point in the same spot. Yeah.
Multiplying is the same or different?
Multiplying is a little different if you're doing it by hand, okay? So back to this one. You can do all that multiplication by hand, but just make sure you put in the 2 decimal places. Yeah. Okay. Fractions and decimals. Yikes. Fractions. All right, we'll handle it. In order to write a fraction as a decimal, we will perform the... Well, I think what I meant to say was we need to divide the denominator into the numerator. Okay, remember that that's always the divisor. Write 13 over 4 as a decimal. 13 divided by 4. Four goes into 13 3 times. Multiply and subtract. You get 1 left over. Now make that decimal point. This is different from the remainders. Okay? Make that decimal point at the end of the number. And see how it goes in that same spot? That's how you know. Now you can add as many zeros as you need. So far so good? Okay. 4 goes into 10 2 times. 4 times 2, 8. Subtract. Sorry, I'm running out of room. Add another 0. And now I think I'm going to have a nice ending to it. 4 goes into 20 5 times. And I'm finished.
So you keep adding on zeros until you reach a decimal point?
Until you reach an ending, yeah.
So until you like get to 0, just keep going.
Mm-hmm.
Or unless it's repeated.
Because this is, yeah, so the trick is if it's going to be repeating or not, but I don't think they'll ask you that. Just because I'm that guy who thinks about numbers in weird ways. Every time you divide by 9, it's going to be a repeating decimal. And every time you divide by 7, it's never going to end.
How do you write that? Like, if you have a problem that's like that, how do you...
Okay, yeah, that's a good question. Repeating decimals. Let me put that, let's see where I put it, right here.
Like a line over it.
If it was a repeating decimal, and for some reason that you got a question and it was like, say, 8/9, when you do that division, 8 divided by 9, you would get a 0 there, make your decimal. So 9 goes into 80 8 times. 9 times 8, multiply, subtract. There's 8 left over. Add another 0, bring it down. And at this point, you recognize the pattern, right? So this would be 0.8 repeating. You'll just see the bar. And that means repeating.
Just a line on top of it?
Just a line on top of it, yeah. If it was, say, let's say I did 30 divided by 11. This turns out to be 2.72 repeating. So now there's two numbers that repeat, and I put the bar over both of them. All right, if you just do that 30 divided by 11 in the calculator, you'll see it. Let's go the other way. In order to change a decimal to a fraction, put the decimal number over 1 and add as many zeros to the denominator as there are decimals. Write 0.84 as a fraction. All right, people of the back, you're up. Write 0.84 as a fraction. I would write 84 over how much?
1.
Put 84 over 1, but add as many zeros as there are decimal digits. So how many digits we got?
2.
So I should put 84 over 100. It will ask you to reduce. The homework problems always do. So now you go back to the last chapter and you say, okay, factors of 84 and 100. I don't know, I could start small. Just do 2. So that would be 42 over 50. I think I can go more. Yeah, and I think that's as far as I can go. Let's do another one. How about 0.125? Your question. How would I write this as a fraction?
125 over 1,000.
Exactly, put it over 1,000. Think about it. The very first thing we talked about, it goes to the thousandth decimal place. So put it over 1,000. And then you got to go through that same process. 25. 25 goes into both of these. So 5 over 40. Thank you. Yeah, I think you're right. 5 over 40.
Can't you, can you understand? What if you divide by 5?
Oh, you're right. Further. Sorry. So you get 1/8. Yep. Okay, good. Couple more minutes. Now here, I'm glad I put part A in there. Now there's a 7 in front of it. So ignore the whole number just for a moment. What would you do with 0.205? Yeah, over 1,000. So 205 over 1,000. And then I have to go through that reduction. What was it? No. 205 divided by 5. 41 over 250. Okay? But just don't forget, see, 7's a whole number, right? So let's just make it a whole number and just write a mixed fraction. I don't think that reduces more because I think 41's a prime number. All right, there's that one. Mixed fraction to decimal. multiply the whole number times the denominator. That would be 15. And then add that numerator. So 17, and put that over the denominator. 17 over 5. Now, in order to write that as a decimal, we can perform that division. That's a 5. 17 minus 15 is 2. Decimal point. Bring the 0 down. 5 goes into 24 times. I think this is 3.4.